Dr. Caelum Shiu is a Regional Scientific Affairs Manager for Abbott's Diagnostics Singapore. He did his PhD in molecular pathology from the National Institute for Medical Research, London, following which he took up a postdoctoral fellowship from Johns Hopkins School of Medicine, US. He has background in molecular biology of infectious disease and experience across American, European, and Asian environments. Dr. Caelum Shiu, please.
Thank you very much for your very kind introduction. Gives me great pleasure to be here today. As I mentioned yesterday, it's my first time visiting Mumbai, and it's been a great experience so far. And yeah, so we have a lot to go through today, and I do apologize for it being somewhat rushed. This is the agenda that I'd like to cover. Some initial concepts for infectious disease testing, and then we'll go into HIV testing, and then hepatitis C, hepatitis B. EBV, we have new assays coming to the market, which needs to be registered. So that might come next year. So it's still quite early to discuss it, but I'll go through what I can. Now, for infectious disease testing, we have three intentions. One is diagnosis. Two is to stage the disease whenever possible. Three is if the disease is being treated, we need to monitor response to treatment. Okay? Now, this is a typical profile for infection. Majority of pathogens will follow this, but I'm using HIV as an example because it's a very well-researched virus. Upon initial infection, you'll have viral markers that elevate, and when the viral load becomes high enough for your body to recognize that there's a pathogen there, then your immune system kicks in with antibody response or cell-mediated response. So at that stage, you'll have antibodies appearing here. Okay, so for testing, we have serological-based assays, which recognize antibodies or viral antigens, viral proteins. So these are direct markers, these are indirect markers. Okay? And then we have tests which detect the genetic material. And I'm not going to go into heavy detail for these assays. Now, what I want to impress upon you is how the selection of a detection platform can impact disease transmission and any national programs you have to target a reduction in prevalence. The early generation assays against HIV, the first and second generation assays, were aimed at detecting the IgG antibodies. Okay, so the antibodies seroconversion, they may appear after day 20, but this would be the IgM actually. The IgG appears much later, maybe after day 40, and these are much higher affinity, very specific. Okay, so those were the first and second generation assays focused on antibody. The third generation assay was focused on measuring IgG. Okay, so we're bringing the detection of infection much earlier. And this is what we call a serodiagnostic window. The time from infection to appearance of the first viral marker, which is nucleic acid, and the appearance of antibody. Okay? So this is a diagnostic window, serodiagnostic window, between RNA appearing and antibody appearing. The only thing you can measure is the viral P24. So this is a fourth generation assay that is on the market mainly for automated systems, which measures both antibody and antigen. But you'll see between the appearance of P24 and RNA, there's still a gap that we cannot close. Okay, it's very hard to close that gap. And most of the time, the recommendations are that if you suspect it is a viral infection and you're not detecting anything, ask the patient to come back a few weeks later, and more likely they'll be positive then. Okay? Now, in the past, a lot of screening assays for viruses have depended upon detecting antibody, the first, second, third generation. I'm going to show you a case study of what happens when you rely on that. So we had a patient here in the US presented to the ER, clinical symptoms of some viral infection, fever. Okay? The subject was tested for HIV antibodies, negative. Subject was discharged. The subject then went on to interact with another negative person, and then they also interacted with another person, okay? So these two subjects, they also manifested clinical symptoms shortly afterwards, and they also went to visit their clinician. They tested negative. Again, the symptoms were non-specific, and these subjects were antibody negative by the HIV assay. So then they were discharged without any treatment, any consultation, and then they had another interaction with another person here. So again, a bit later, this person here, symptoms, sees a doctor, test is negative again, no antibodies to HIV. So you can see, by relying on antibody testing, you did not prevent transmission of HIV. Okay? And what happened afterwards was, this was back in July when he first presented. So by December, this person's now antibody positive. Everyone's antibody positive. Okay? So you can see by missing one acute HIV infection who would be seronegative, but RNA positive, and potentially P24 positive, this subject infected 5 others eventually. Now, in Canada, they estimated the majority of HIV transmissions are attributable to such patients, those in the acute HIV infection phase, which is before the appearance of antibodies. So 10% of these AHI cases accounted for nearly 50% of transmissions. Okay, that's very high. And this is because during that period of acute infection, your viremia is at the highest level. Your immune system has not kicked in. You have no T cell response, you have no B cell response. And so at that state, the individuals are able to transmit viruses more effectively. And this is true for hepatitis B, hepatitis C as well. Okay, so what you hear for HIV here, you carry it over to the subsequent viruses we'll talk about. Now, the algorithm for HIV testing, every country should have their own, and the development of the testing algorithm depends on the prevalence of disease, what variants you have. So HIV-2 is commonly overlooked because many people think it's only in Africa, but it's not. It's well established in America as well, and Europe, and also India. Historical data indicates HIV-2 is in India. But how much HIV-2 testing is currently being done? Anyone know? Has anyone had an HIV-2 Western blot? Okay, so everyone's looking at HIV-1, but HIV-2 still causes AIDS. Okay, and we'll go into the algorithm. But the important thing to remember is seldom is there an assay which offers 100% sensitivity with 100% specificity. You should expect false positives with a screening assay, and then using an algorithm, confirmatory testing, you should be able to eliminate false positives. They should be labeled as indeterminate or negative. Okay? Now, obviously, you don't want an assay that throws out so much false positive. But likewise, you don't want an assay that gives you false negatives. Okay, so there is a cost. So this is a typical HIV testing algorithm. Yesterday we had the NACO algorithm. I don't have that slide. But most algorithms lead with an HIV-1 and an HIV-2 immunoassay. So this detects antibodies to both HIV-1 and HIV-2. If reactive, you follow up with another assay, commonly a Western blot for antibodies. And most of the time, the Western blot is for HIV-1. So what happens if you have HIV-2? You're positive here, you'll be negative here. And then you'll have to spend time, if the clinician is sharp, if the pathologist is sharp, they'll consider, what if it's HIV-2? Because we have HIV-2 in the country. So then you have to go on subsequent testing for HIV-2, which costs you time, and it costs money in another test to be done. And sometimes the assay, it may reflex to nucleic acid testing as well, if your facility has that capability, or you may outsource that. But regardless, nucleic acid testing is not cheap, and it's not that fast. Okay? Now, if you have acute HIV infection, where you have no antibody but P24, if you're using the latest 4th generation assays, what you'll find is you'll be positive here, but because you have no antibody, you'll be negative here. And people will accuse this assay of being a false positive when it's not true. Okay, so you can see an algorithm, you have to design it so that the confirmatory test strategy will confirm the initial screening result. By having inadequate choice in the confirmatory assay, you're setting up to challenge results as being false positive, and you'll lose time in the diagnosis. Okay? So actually, this is to show you, in India, this was published 2010, they surveyed a number of individuals in Mumbai, 524, and they picked out 28 with HIV-2. Okay, and 7 had a dual infection. So do you think this warrants testing for HIV-2 in India? That's good. So most countries in South Asia do not. Okay, so now the thing they notice here is that in this publication, the majority of individuals presented at late stage. It's not an early diagnosis. So this is something about HIV-2. It tends to not cause clinical disease like HIV-1. So patients don't go to the doctor in the early stage because they're feeling sick.
We have many rapid devices which have both 1 and no. So most of the 2s won't be picked up if they are positive.
Okay. So those probably came after 2010, I imagine. So it probably warrants a new study into the detection rate nowadays. Yeah, before 2010.
We do by 3 methods when positive.